So in this meeting, I want to mainly show a library to validate data called IoTS. But in order to do that, I have to speak a little bit about other stuff. So I'll try not to stop so much in details, or maybe we can split this talk in two if it starts taking too long. It's being recorded anyways. So I want to, before I speak about the IoTS itself, I want to talk about a little bit of type safety. Because, for instance, you see my screen, now it's bigger. Can you see my screen? Okay.
Yes.
Yeah. I create this function, as you can see, imported here, get gems. Oops. Thanks. So if we see the type here, can you see down there in the bottom of my screen the types showing? So I will pass a quantity, that's a number, and I will get a list of names, at least a list of strings. So when we're talking about using types, we want more than safety, because I can't pass something like that here. It will throw me, say I can't, because I don't know why it isn't showing, to be honest, but it should. Okay. Damn, technical problems here. Anyway, yes. So I can't pass a string because it's waiting for a number. But more than this kind of type safety, we want to know about the functions, about what it does, what it returns. So when I see the name and I see the type, I'm waiting. If I pass some number, it will return me some list of strings. For instance, like this. These are us. We have here 6 people because we passed the number 6. And but what happens if we pass something like that? If we pass 9, we are not 9. We know that, but some person that might use this function doesn't know, because the function doesn't have any kind of constraints. Just say, see, you have no errors here. It's waiting for a number, and it's saying it will return me a list of strings. So if I execute that, oops, we got an error. Our function broke our program. Now we have error. We returned 500 in our backend application. Our data dogs just exploding with errors. We don't know how, because this function was just showing that we expecting a number and we return a list of strings. So if you see here, I create another function with not so good name, but I needed 2 different names for the same function. So I create get gems engineer safe. That's if I pass, let's see the type first. The type is waiting for the quantity, a number, and it's saying the return type is this strange type called either. I don't know if you have some familiarity with this. It's something based on Haskell, but a lot of new languages use stuff like that. I think Rust has some kind of error handling like this. That what's happening. So this function will either return me a string that's, to be honest, it should appear, if you see here, an error message that just a name that I gave to a string. So I wasn't supposed to show you the function. It was just a mystery of using the function based on the name or the types and the types. So if it will return me either error message that is string and the what I'm expecting, that's a list of strings. It's a convention, the either type, the left one is sort of reserved for errors, but you can use for any time you want to return two different kind of stuff, but it's usually used to handle errors. So it will be the left side is error, and the right side is what you were expecting, what when the result is right. So it's a pun. So in this case, what this strange type will return me here. So ignore, for instance, here this tag right, and we can see when we console log this that we have the expected stuff type. We have me, Lucas, Gabi, TK, Denise, and Mohammed. I asked Mohammed first if I was writing his name correctly. Denise, I know, but Mohammed, I have no idea if this is correct or not. So, and we have this tag that says right. So let's get an example. For instance, let's pass 6.7. We can have this. So we now have the tag left that says that our function returned the left side of the either. It was either error message or either the correct result that we're expecting the list of names. If you remember, the error is now different from that one. If I try to just pass 7, it will say that's too large. If I try to pass some negative number, it will say quantity must be bigger than 0. If we see the functions, it's very similar here. The first one, I create 3 throwing errors. And the second one, I return the left side or the right side here. I will get into these details. You don't have to worry about that. I just wanted to show the 3 different errors. Because we have another type that's similar to it, that's called option. A lot of languages have stuff like that. In Haskell, it's called maybe. But here in this library, the library is called FPTS for functional programming. That when you want just return something that could be not. Sometimes you use this a lot with we put the return of the function, something like that. Some string null or string undefined, and we try that. The optional type is a way to do it more clearly in a more beautiful way. And because for now it's strange, but in the further in this presentation, I will show something cool that we can do with these types. So let's suppose here that we calling this function and we want to do stuff with the result. So let's create some function here, like my function. Sorry about the bad name. If we pass a number. Okay. So now we know, because we already have to roll back some PRs, that this function that we're using can throw errors. So let's do the try catch way. Try catch here, so we can put this get ends. Let's put some here the number in our catch error. So let's still keep throwing errors, because let's maintain the bad pattern of throwing errors throughout the code. So let's throw a new error. Let's say that we just want to put some concatenating some message like, oh no. And here I think we have to do something like this or some kind of stuff. So JavaScript wants say anything, and that's message, right? Let's see, if you want to do something with the result when it's correct. In promises, we could use just then and catch the similar array, but we could just return. So we're keeping the type here. Let's just keep the type here. string. Let's return like, let's put everything to uppercase. Uppercase without end. Okay, if we try to execute that with some valid results, I don't know if we do change the Persian letters, but the others I know it's have a result. Okay, in this case, we could apply the changes we wanted to do with this result. Let's give an example here with incorrect result. So we throw in an error, but with the oh no, that we wanted to do that. And you can say, so if we use the type saved one, what could we do? So let's create a very creative number, a very creative function name here. The same, let's just, I want to put a return type here because maybe I want to do something first. So we could put this like ends instead of get, say, and if we see here, we know the return of this function is this either string error message or the names we want, right? Let me just put an example here that I could start with first. So in this case, specifically, we know it's right? So we pass here, we see the result, we know we have this tag, and we know we have this right here. And if this is some wrong result, we see that we have the tag left and the left key. And you might be saying, how can we access that? If I try to do that, I can only put the tag. If I try to put the left, it does not exist, or the right. So you might be asking how we access this result. We have some functions here. So the FPTS has a lot of, we have this either, we have optional, we have something called task either. I want to get in here because it's some about the future. We have some task that's talking about the future, but that's not the point here. So that's why I will be important stuff like that. Okay, Denise? I can hear you.
Yeah. Do I get it right that for now we have incorrect function description? So the no, this not description. Forgot the word. So description at bottom says that our function must return string or array, but it returns an object. So is it wrong or something? I don't know.
No, it's
because
the return of this function said it will return on neither string or so this either will always be something like that. Like for instance, -9. It always have this tag and will be either left or right. And now I will show you how we get this information.
Oh,
it's actually I didn't see the implementation, but I did in our code something similar. Since I didn't have talked about this yet, I created something like it's like a sum type. When you have a sum type, your code doesn't know which of the sum types you are. Just do something like that. I don't know. I would say that either will probably be defined for something. If I have to define with the knowledge I have, I would do something like that. It will be some the tag here will be right or left, and we could have this left, that would be type A. And here we would do the same, oh, like this actually. And we do have the same type here, but with right, A, B, and here we have right, something like that. So if we are using this type here, let's call it my idle. We can't know if we have which one that we are. That's the case here. We know it's an either, but I can access the left or the right. The way we do that is something like that. There is this function that's called, for instance, is left. So it checks if our engineers here variable is a left. So here we can call outside. We can't. So if we do something like that, so I will do in the same order there to be first here we're doing the right side, here doing the left side. So I will do the opposite here if it's right. So here we return. So we did just add to upper with our ends, right? Here I have to put the typing. The typing is either string, right? And here we could, since we are returning, we know for sure that here we have the left side. Because if it's right, it's inside this block. And since we are returning, the outside part of the block is a right part, it's a left part. So we could just return not concat. Let's say, oh no, without any step left. So we see that we have two type errors here because this is a list of strings, right? This is, and this is a string. So the return type should be in an either. So what we can do there, we have a function. I hate that here. So this one is now correct, type safe, and this is left. One thing that when you do stuff like that, you are obliged to treat the errors because the type will say you have to. You can access the right part of this if you don't treat it. You can access the left part if you don't check. So instead of, but one thing you might be thinking right now, so you're putting this huge amount of complexity and information and weird types to do something that's just very similar to what we saw in the first block here. And I did it on purpose. I did it very similar on purpose. But let's digress a little bit. Now I have to digress a little bit to explain how the either can be awesome instead of try, catch, then, and etc., 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 if we're talking about promises. So let's think a little bit here. Let's create, I would just call, just to be very clear, instead of writing this, I will write this to sort of envelope what the type inside. So for instance, we can do that. Well, some const a, it will be a list of string that will be like Mohammed in our letters. Okay, this is completely okay. It's just saying that I'm not using this value, but it's okay. So let's say we have this, and now let me just put another stuff. Let's create a type called a function, an array function. What's an array function? An array function is a function that has an argument, type A, and return B. Some example of an array function. For instance, the function to upper, or the function length. Okay. We would say that is a function that goes from a string to a number. And we have here some string, and we return string from sorry. Here. So this is a function that goes from string to number. If I want to apply this function here in a name, for instance, something like that, and I call this length function, okay, it came from string and got to a number. Another example, like the upper function that we were talking about, it will be a function that the parameter is a string and return string. So it will be, we can just let Lambda do the magic for us, and we don't have to care about that. And we could, that's going to put here to upper. So it's working as expected. And why am I doing this? Now, we have these functions here that goes from a value to another. And here we have this function. So what if I want to apply, and for just for the educational purpose, let's suppose the list has always one element ever, okay? I don't know why the hell would we do that, but let's suppose that our type here has always one element, like this one. So if I want to apply one of these functions here, let's say I want to create a function here called, for instance, list length. Okay, let's list to upper, it will be better. That's will be, let's just is it to be confused? I'm stopping every time and putting stuff like that. But let's create a function that a type that's called a list function that have type A for type B. That will be here. We have list A, and we return a list of B. Don't know if it's getting something quite okay. Let's continue. So let's create this function here, list to upper, that will be very similar to that one before. No, list fn. We know that upper is string to string, so we want to get a list of string and return a list of strings. So here we have our list. Okay, so what's the most obvious way to do that? Of course, we would get the element here, right? List 0, and we would return the to upper function to our element. But the type's wrong because to upper returns a string, and we want to return a list of strings, right? The return type here should be a list, so it's wrong. So we would do that. It's type safe now. If I say list to upper in our a variable there, we will see that it works. So do you agree this is the most obvious way? Of course not, right? We have a very easy way to do that. That's called map, right? That can just the to upper, and we pass our A, and we do exactly what we wanted. Instead of doing this, we just map a function inside the value. That's what's happening here. That's what map do. The name of it, if you are a nerd like me, it's a functor. The functor is a structure, it's when you can map functions to its values. So a map, what's a type of a map? It will receive a function. Let's put an A and B. It will receive a function here. The function is that one that we saw that like this one. We will receive a function that gets one value and return another value. Can't be the same type, can be different types, no problem. So it will receive a function and it will return a list function. That is, if I do that like this is exactly the same type as this. Not this one that I wrote, but this is from Lambda, so it will have this proper name. But if you see there, you see that's a map from string to string, because it's a mapping a list of string to a list of strings. If we put like length, it should be a list and number. So if you see here, it's now a string number down there in the bottom. What's happening in here, I can apply a string here. I must be applying a list. So this function here on say list length is returning, it is waiting for a list. So if I say this list length A, it will return me what I want, right? And now, why did I talk about that? Because in general, we use maps for lists, because that's what JavaScript gives us. But we can actually map everything that, of course, you have to write the map function for your type. That's why we already have this here. So instead of what we did here, if you think about, is exactly this. We get the elements from the envelope, the box. What's the box here? The box here is the list, right? We get the box, the element from this box. We apply the function on this element, like here. And after that, we put the box again. When we see here, it sounds ridiculous. It should sound ridiculous here too, because that's a waste of time. We should be able to put it in a more direct way. So I will just write down here to be more clear the difference. We could put this my function 3. The best part of this presentation is the function names. So we return an either. Of course, let's suppose now we are talking here about a lot of endpoint calls and another stuff that we do in an application. Now we are not getting engineers' names in a function that throw errors because I wanted to. So in this case, what we do, we always pass the error to forward, or the result forward. And of course, in the outside part of your application, for instance, the controller part, the main part of the Lambda function, you will have to take the value off. Either to throw an error, something like 404, user not found, and I know that because it will be this part, it will be an error here called user not found. But maybe this user not found, it was in the beginning, but a lot of stuff would happen after, but I know that it didn't happen because we have this error here. And I know which part and exactly what error we have. So in the time when we want to return what we have to the client, we can't just, we take this off. And this part, it's inevitable. You take this off and return, okay, return 200 with our body, that's okay. Or here we return 400, 404, it depends on each error we will get. So it depends on the application, but the point is, you won't have surprises because the error will be always there, treated, also the good part. So let's give an example here, how to do this in a cooler way. So let's use our pipe here, our run this pipe. So let's first get our engineers. So we want to put everything to upper, right? No problem. So map here. This is under string. What am I doing wrong here? Quantity number. Okay. I have to put it. Let me just do this and this and this. Now that's okay. If I try to execute this, let's put we again. And we see the expected value we wanted in the right side. Because what this map does this. It checks if we are on the right side and it apply a function only to the right side. Let's give an example here of left side. Nothing changed. It's not quantity too large in upper strings or nothing happened. We just applied on the right side. And you might be asking yourselves, hey, what if I want to apply a function to the left side? Well, couldn't get more obvious here. So let's do exactly what we did there. Concat our, oh no. And if we do this here, we applied only on the left side. So that's the magic. You're doing stuff with the either. You want to apply functions only on the right side, you can apply. You want to apply functions only on the left side, you can apply. Since we're getting out of time, I will just copy here this. Let's say this is one problem. Here, it starts to get a little bit uglier. I would give a name for this. Because here, this map, this is the part that might get confusing. I wouldn't write this in a code because it's map inside map inside map, it's weird. This map, it's about the either. We are mapping in the right side of the either. It could be called map rights, but it's not. It's called map because functors in general called map. In this case, we have two possible values. It's generally one. So if we were talking about that optional type that's in Haskell called maybe, I think Java has optional Java. So stuff like that, you cannot have one value. So map, have no confusion. So map is always like that. You apply a function inside of your box. It takes out of the box, apply the function, put the box again. So you don't have to do that. It does for you. But we could have a more complex function, let's say, oops. Here, that's, we see, here we are expecting a list of engineers and return only string that is just a cool formatting about the names. We could do that here now. Instead of mapping, see, it's the errors are already coming because this is returning a list on the right side and now it's expecting a list. So here we have format. Now it's more clear because we don't have to deal with maps inside maps. Suppose we'd have maps here or joins. We could do that a lot of, we could have stuff like that, for instance. Map to upper, join, and then concact. It would work, but in my opinion, it will be a little bit harder to read. I prefer to create a function that say what's happening and put here. Now it's a little bit, it's clear. We have this result here. This result would be on either left or right. So we want to map something on the right side, and we want to map something on the left side. let's see here. Oh no, quantity is too large, or oh no, it should be integer or bigger than 0, or I don't know, maybe that will show a different error. That's why I like this example. It's very silly, but I can have 3 different errors that I can show you. So let's put a correct number here. So the right side now is string that James engineer are in our names.